So the next problem I want to talk about is capacitors that are in series and the amount of charge and the amount of energy stored. Okay, so three capacitors, absolutely identical. Here's my power supply. Let's make sure I differentiate that. Now, the question I'm asking is how much charge is stored and how much total charge is stored. So how much charge is stored in each one of these capacitors? And how much total charge is stored in this capacitor? Now, the important thing you got to realize about parallel or in series capacitors is that I move a charge from here and it goes to here, which moves the charge from here to go to here, and then liberates a charge. So it turns out that all of these store the exact same amount of charge. Okay? And then if I were to remove my capacitor and put a resistor in its place so that the energy is going to move through the circuit, the total amount of charge is going to be, remove that section, it's going to be these two plates. They're going to store the total amount of charge. All the charge in between it is just going to negate itself here. Okay? So the total charge here is actually going to be equal to the charge stored at each one of those capacitor plates. Okay? So it really makes makes this problem simple, because we're going back to that idea of Q equals CV. Okay? My V is going to be my V total, and my C is going to be my equivalent. Okay? And when coming up with equivalent capacitors, 1 over C equivalent is equal to 1 over capacitor 1 plus capacitor 2 plus 3. Capacitors over and over and over again, inversely. Okay? And then you get your equivalent capacitor. So for this, I'm going to have, well, they're all identical in this case, because that's the way the problem is set up. So 3. So I'm going to end up with 3 over C. So my is equal to 1 over capacitor equivalence. Now that's because the capacitors are equivalent. If they're not, you need to use the common denominator and get them all to add together. So I get 1 over C. So my equivalent capacitor is 1/3 my original capacitor. Okay? So that means that my total charge is equal to 1/3 my original capacitor, this capacitor, or this one, because all three of them are the same, times voltage total. That's your answer. Okay? Cool? So when dealing with capacitors in series, it's a lot easier to calculate total charge, or charges equal to each other.